Hi all the students of Narayana 9th standard. Today here I am in front of y'all to discuss a assignment 26, and the topic is work power energy. Let us go with the first solution which they have given us. The question which they have given over here is a motor of power 2.45 kilowatt draws water from a well of depth 20 meters. If it fills a tank of capacity 3000 liters in 7 minutes, the height of the tank above the ground is. Now let us try to give all the given data. We'll write it like power is given as 2.45 kilowatts, which I can write it like 2450 watts, and draws a water from the well of high depth is given 20 meters, and they have also gave you if it fills a tank of capacity 3000 liters, then what you would be doing is a tank of capacity 3000 liters. So if you want to get capacity of tank is 3000 liters, so I can write it in terms of volume. That means my volume is going to be around somewhat 3000 into 10 to the power minus 3 meter cube. So this is my volume, and the time which it has taken is 7 minutes, which I will write it as 7 into 60. Now what they are asking you, like gravity, which you can take it like 9.8. the height of the tank they are asking you. They want the height. Depth is given, height is not given. Height is equals to question mark. Now we know that power formula P is equals to mgh by T, where we already know P, which is 2450 is equals to mass is nothing but 3000, volume. Mass is nothing but we have a capacity fills water. So if you want to talk about the water, your density is going to be we'll be writing it as rho density into volume. M is going to be written as density into volume. So density of water we'll take it as 10 power 3. Volume you will be taking it as 3000 into 10 power minus 3 into gravity is 10. Height will be written like depth plus height. So we'll take it as D plus H. D plus H is the total height to which the water is lifted. Now by time is given as 7 minutes into 60 seconds. So you will be getting like, if you see here, if you try to calculate over here, this 10 power minus 3 and 10 power 3 are going to get cancelled, and you can even cancel the 0, 6 ones, 6 50s, and you will be having 50 into 10. So D is also given for you. D is given as 20. So now if you observe here, you would be getting somewhat around like 50. So we are taking 9.8 over here. 9.8 gravity, we will take it as gravity mgh, right? Gravity will take it as 9.8. So when we take it as 9.8, you're going to get it like 50 into 9.8, that is 5 into 10 into 9.8, and you're going to get it like 5 into 98 by 7 into 20 plus h. Right? Now you are going to take 2450, and here if you observe, you can take 490, 7 ones, and you are going to get like, so what I'll write it over here. 2450 is equals to 490 by 20 plus h 7. So you are going to get 7 ones, 7 70s, right? Now this 0 gets cancelled, and you are going to get left over with, I'm going to write it over here. So 245 by 7, this 7 comes this side, is equals to 20 plus h. Now I want the value of h over here. Now 7 ones, 7 3s are 21, and 7 5s are 35. So h is equals to, that implies h is equals to 35 minus 20, which is 15 meters. 35 minus 20, which is 15 meters. So your option is third option. Hope this is helpful for you. Let us move on to the next question. Let us discuss this second question. Again, a train of mass 400 metric tons is moving with a velocity of 18 km per hour. With the application of force, with application of force, its velocity changes to nu. That means because of applying some force, its velocity got changed in 2 minutes. Time taken is 2 minutes. If the power of the engine is 10 megawatt, the value of nu, that means velocity to what it has increased, have to be found out by you. Now we are clearly understanding that the velocity is changed over here. So the power formula is equals to half mv square minus half mu square, because there is change in energy, change in velocity. That means the energy is also going to change, the kinetic energy is going to get changed by time. So you take half m common, half m you take common, will be getting v square minus u square by t. So now let us substitute the values. So p value is given 400 metric tons. 400 metric tons can be written as 4 into 10 power 6. 4 into 10 power 6 kgs. Mass, right? Sorry. Power, how much they give? Power is 10 megawatts. Power, you will be writing it like 10 into 10 power 6. Mega means 10 power 6. You are going to write it in watts. And half m is given as, mass is given as, see this is power and this is mass. Sorry, I have told little disturbings for you. Now 400 metric ton is mass. Now in the place of mass you are going to substitute it like 4 into 10 to the power 6 kgs. 4 into 10 to the power 6 kgs. You convert that metric ton into kgs, you are going to get 4 into 10 to the power 6 kgs. And velocity, that is final velocity which you have to find, was given like nu. So I am substituting it as mu square minus u square is given, that is initial velocity. So what is the initial velocity? They gave it as 18 km per hour. We'll convert it into meter per second. So 18 km per hour, if you convert it into meter per second, you are going to get 5 meter per second. So I am going to write it as 5 square by t. T is given as 2 minutes, so I am writing it as 2 into 60. 2 into 60. So now let us start solving this. Now you are going to get 10 power 6, 10 power 6 gets cancelled, and 2 ones are 2 fours are 2 twos are, right? So and this 2 and this 2 gets cancelled. You're going to left over with 60 into 10, which is nothing but 600. 60 comes this side, 600 is equals to v square minus 25. V square minus 25. So from here v square is equals to 625, which is equals to v is equals to root 625, which is equals to 25. So v value is 25 meter per second. But in the options they asked you to, in the question they asked you to find like kilometer per hour. If you want to convert this into kilometer per hour, you will be converting like 25 into 18 by 5. Okay, now 5 ones are 5 5s are. Is 5 into 18 is 90 kilometer per hour. So this is your velocity, which is nothing but mu is equals to 90 kilometer per hour. So which option it is? It is option number 2. Hope this is helpful for you. Let us go with the next question. Right. Now a motor pump is delivering water at a certain rate. In order to increase the rate of delivery by 100%, the power of the motor is to be increased by. So how much rate of power have to be increased? Now let us try to solve this problem. Now when you try to solve this problem, we have a relation like power formula P is equals to mgh by time. Now from this formula, if you try to solve this, P is equals to mass into acceleration. This is g is nothing but acceleration. So whenever a motor power is delivered water at a certain rate, that means the rate is going to be denoted like dm by dt, which is directly proportional to the velocity. The rate of power, the rate of delivering water will be directly proportional to how much of velocity the water is delivered now next, if you want to increase the rate of delivery by 100%, that means if you increase this by 100%, in what terms you could explain that power is getting increased? So when you want to get a relation for power and velocity, then we'll try to derive the velocity formula, a relation between power and velocity, by using a dimensional analysis method. Like we'll be try to figure out the dimensional formula of power from here. Dimensional power of power is nothing but mass, you can write it as capital M. G is nothing but acceleration. Acceleration formula is velocity by time. So next, h is nothing but length, so we'll take it as L. So this one we'll take it as capital T, and this is T, which is capital T. Now from here the dimensional formula is going to be m. V is nothing but displacement by time into L. So again S over here is nothing but L. I am going to write it as L. S is nothing but displacement, so I am writing it as L. So my dimensional formula of power is nothing but m L square t power minus 3. ml square t power minus 3. This is the dimensional power of formula of power. Now after getting this dimensional formula, we will try to convert it into the relation of velocity, power and velocity. Now when you want to convert this dimensional formula relationship into velocity, you just multiply it like P, you multiply dimensional formula of power, which is ml square t power minus 3 with L cube and divide it with L cube. Now what happens over here is m by L cube is equals to m by L cube into L square into L cube by T cube. So you can write this as mass by volume, m and L cube. L cube is the dimensional formula of volume, so you can write it as mass by volume is nothing but density, which this is the dimensional formula of power. So I am going to write it as mass by volume as density. L square is the dimensional formula of area, so I am writing it as A. L cube by T cube is the dimensional formula of displacement by time, is nothing but velocity, so I am going to write it as velocity, and it is in the terms of power 3, so I am going to write it as velocity cube. From this I can denote that power formula can also be written like density into area into volume, velocity cube. So from here I have given you the dimensional, from the dimensional analysis point of view, I have given you the relationship between the power and velocity. Now we have to calculate the increase in power percentage. Now when you want to calculate the increase in power percentage, from this formula we can easily tell that power is directly proportional to the velocity cube. That means when you try to figure out the percentage, I am going to use this space. Right. Now you can write it like P power, final power minus initial power by initial power into 100 is going to be equal to, in terms of velocity if you write, you are going to get final velocity cube minus initial velocity cube by initial velocity cube, so into 100. Now this is, you can easily that is directly proportional to velocity cube, so you can write it in that way. Now for example, they are saying 100% of increase. That means imagine if initially it is increased with 100, that means I am going to substitute that v square v2 cube minus v1 cube by v1 cube. I am going to substitute it in this way. Like if I take initially, if it is 100, because I am trying to calculate it in the form of percentages, so now I am going to write it like 200 because it is increased. If it is increased, to be increased by 100%, the power of the motor is to be increased, how much we don't know, but the rate of delivery is increasing 100%. Initially if it is 100 and if it is increasing 100, then it is going to be 200. So this is finally it has got increased for 100 plus 100, it is 200 cube minus initially it is 100 cube by 100 cube into 100. So now what happens from here, you take 100 as common into 2 cube minus 1 cube by 100 cube you have taken as common, 100 cube into 100. So from here 100 cube and 100 cube gets cancelled and you will be left over with 2 cube minus 1 cube into 100. So from here what you can write it? You can write it like 2 cube is 8 minus 1 into 100. So how much you are going to get? It is somewhat around 700%. It is somewhat 700. So the percentage increase in the power is going to be around some 700% if you increase the rate of delivery up to 100%. If you increase, your power is going to get increased for 100%. Now this is how it is going to be solved. I hope this is helpful for you. Let us meet in the next assignment. Bye.